Yeah, hello, hardworking learners. Welcome to this very important tutorial. In our previous tutorials, we discussed extensively about how to graph linear functions and quadratic functions. In this tutorial, we'll be looking at how to graph trigonometric functions or draw graphs of trigonometric functions. Alright, so we'll begin. Our presenter, Francis, will lead us.
Alright, so for trigonometric functions, they are a bit different from the algebraic ones. Taking sine x for instance, look at how the graph is. You realize that after every period of 2 pi, after every 2 pi, so the graph is the same. So from 0 to 2 pi is the same as from 2 pi to 4 pi. I hope you're getting it.
Yes.
And we continue like that. From 4 pi to 6 pi, it will also be the same.
I've observed that it's like a wave.
It's like a wave.
Okay.
So they are called sinusoidal functions when it comes to science.
Functions. Okay.
Science. So the same thing applies to the cosine function also. So I'm sure you are familiar with this function, the cos, the sine, because we did them in trigonometry 1.
Yes, I've seen them.
Okay, good. So what we are going to do mainly in this is how to draw tables or fill tables for trig functions and use it to graph.
Okay.
So graphs of trigonometric function, that is what the trigonometric 2 is mainly about. So we are going to look at how the graphing software was able to graph the trig function, the sine y equals sine x. We are going to do it with our graphs so that we can get the same shape as this. So in order to do that, we need to draw a table of values. So what we do is that we have the interval from 0 to 360 degrees. In terms of radians, we'll say that from 0 to 2 pi.
Okay.
So this is the function like f of x equals sine x or y equals sine x. So in order to find the value of this for y, we plug in the value of x over here. So if you have your calculator,
okay, so I think we can use calculator to verify that.
So you take your
sine 0 gives us 0. Sine 90 1.
Sine 180 0. Sine 270 is what? -1, and 360 is 0.
Okay.
I hope you're getting it.
Yes.
So now the next thing we do is
we'll plot the points.
To plot the points.
So 0, when x is 0, we're getting the y to also be 0.
Good. So we plot 0 against 0. So it will be the origin over here.
Good.
Then the next one is what? 90 degrees against 1. So we plot it over here.
180 0.
Then the next one is 180 0 over here. The next one is 217 against -1, which is here.
Yeah.
This is supposed to be -1.
Yes.
Then 360 against 0. So now we draw a smooth curve.
It means we will not use ruler to draw the line.
No, just use your free hand. So you draw a smooth curve through all the points and look at how it goes smoothly.
Wow.
Alright.
This is nice.
Good. So that is as simple as that. As simple as that. So looking at this graph, you can see that we have the graph not going beyond some number.
Yes.
I hope you're getting it.
I've realized that the highest it was able to go, that's 1.
1.
and came down to just -1.
So the 1 and -1 are called the maximum and the minimum values, respectively. I hope you're getting it.
The maximum value is 1, and the minimum is -1.
Good.
Now you were talking about period.
Yeah.
So this graph, how many periods do we have here?
Good. That's a very nice question. So this is only one period.
One period.
Good.
And we can also say it's one cycle.
One cycle. So if we should continue again to, let's say, 720, then it will be here, and you see that the same graph will reflect over here.
Very good.
Now, if you have this also, this time the interval is not 0 to, the interval is 0 to 360 degrees. All right, but
we have changed
the steps.
Yeah.
The step is 45 degrees, unlike the previous one.
In the previous case, we are using 90.
The step of 90 degrees. Yeah. So they will indicate it in the question which step you should move. And to complete the table, it's just a matter of plugging in the functions, the value of x into the function, then you get the corresponding value of y, then you plot the points. So over here we plot 0 against 0 again. Then the next one is what?
45 against
2 over 2.
So this root 2 over 2, how do we determine it?
Yeah, so use a calculator.
Okay.
And find root 2 over 2 to be 1.4. So 0.70.
Yeah.
So I think that will be 0.7. Yeah. So this is 0.1. This is 10. Down it.
Yes, yes.
So each box is 0.1. So yeah. 0.1, 0.2, 0.3, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. We somewhere here.
Yes.
I hope you're getting it.
Yeah.
Then the next one is 1 against 90. So here. And the next one is, isn't it?
Yes. So
good.
So then
the next one is 0 over here. So after that, we draw a smooth curve through it. Just smooth like that. So that is how to draw the graph of trig functions.
Okay. Nice.
So for the cosine, you're going to repeat the same step, and after drawing the graph, it should look like this. It should look like this.
So with the cosine tool, we just plug the x values into
the function
and get the corresponding y values.
Then you plot them.
Then draw the smooth line connecting all the points.
So once again, what is the highest value and the minimum value?
The highest here is still 1. The minimum is -1.
Do you know why we are getting 1 in each case?
No, I don't quite get it.
It's because of the coefficient of the cosine over here. It's 1.
So that is mean if it becomes 2, we'll get the highest to be 2.
Good. The highest will be 2. If we have cos x over here. If nothing has changed apart from
the coefficient
of the cos x,
then that becomes the maximum value.
Maximum or minimum value. That determines the minimum.
I'll go and verify that.
That's
I'll verify that.
Good.